Hi everyone, thanks for tuning in for another math lesson. If you don't have your Go Math book, make sure you pause this video and go grab it along with a pencil. Today we're going to work on chapter 12, lesson 2. So, in this lesson, boys and girls, we're going to learn 3 new vocabulary words. And some of the words that I'm going to teach you are not in our book. We're going to learn about angles, and our book only talks about a right angle and then angles that are greater than a right and less than a right. But I'm going to go through what we call those types of angles, so you're going to learn a little bit more than our math book even teaches us. So let's go ahead and get started. All right, lesson 12.2 starts on page 703. We're going to describe angles in plane shapes. Remember, yesterday we learned that a plane shape is a flat shape on a piece of paper. It covers just one plane, a flat plane. So an angle is formed by 2 rays that share an endpoint. Remember, we learned about a ray yesterday, boys and girls. A ray is part of a line. It has an endpoint, though. Let me make this a different color. Okay, so it has an endpoint, and then it continues on forever in one direction. That's a ray. But today we're going to talk about angles, and an angle is formed when you put 2 rays together, such as this. And when those 2 rays come together and they share the same endpoint, that endpoint is called a vertex. Okay, the plural of vertex is vertices, which is a grammar lesson for another day. So if we take a look under our Unlock the Problem, it says that Jason drew this shape on dot paper. How many angles are in Jason's shape? So again, an angle is formed when we have 2 rays come together. And so we could look at this top corner, and these 2 rays or segments are coming together because this is a closed shape, so now these would be segments. So the space in here would be 1 angle. Then we have this bottom corner of the shape, so that's a second angle. And these are perfect corners, by the way. Then up here in the top right, we have another angle formed by those 2 segments. And then in the bottom corner, we have an angle formed. So altogether, there are 4 angles in Jason's shape. Boys and girls, let me tell you a little secret. If a shape has 4 sides, 1, 2, 3, 4, it will also have 4 angles. So if a shape has 3 sides, it will have 3 angles. If a shape has 6 sides, it will have 6 angles. So that's a little trick. All right, so let's look at the angles in the shape that Jason drew below. How can you describe the angles? Here's where we're going to start to learn some math terms to describe the angles. So if we look at the first shape that Jason drew, it has 4 sides to it. And for these angles, this top corner and the bottom corner, you can see how there was a little square drawn. That symbol, boys and girls, is a special symbol that tells us that this is a right angle. A right angle forms a square corner. It's perfect. It is just right. So anytime we have that perfect corner, that creates a right angle. So in Jason's shape, he has 2 right angles, 2 angles that are right. Then in the middle shape, we look at this angle formed by these 2 line segments. It seems to be like it's closing in, it's pinching in a little bit. So this angle is less than a right angle. But let me tell you what we would call that type of angle. So right here is a right angle again, and a right angle forms a perfect corner. And usually it is shown by that little box in the corner. So that's a quick, easy symbol to tell us that this is a right angle. It's perfect. It is just right. Then, as we just saw in our book, some angles are less than a right angle, and they are called acute. When you think of tiny little kittens and puppies and little babies that are just so teeny tiny, and we might say, oh, they're so cute because they're so small. Hi, Sadie. These angles that are pinching in and are less than a right angle are called acute angles. So these three angles I drew on my paper are acute. They are so teeny tiny. They are closing in. They are acute angles. So that's the mathematical word for an angle that is less than a right angle. Okay, and then there is another type of angle, as you can see in your book, for an angle that is greater than a right angle, and that has a special name too. Obtuse. Obtuse is a word that means big. So these angles, if you look at how they are opening up, they are really wide. They're stretching out. So those angles are called obtuse angles. They are greater than 90 degrees because a perfect 90-degree angle forms a perfect corner, but this one is opening up more. So it is obtuse. Now I wanted to share a couple items around my house that I found that have angles on them, such as a picture frame. Here's a picture of my kitty Jasper. A picture frame, when you think of the edges of a picture frame coming together, they create angles. So when you have shapes like squares and rectangles, and a lot of things are made of squares and rectangles, they create these perfect corners. And so this is an example of an object that has perfect, just right angles. And so these are all right angles. You can see the pictures behind me on the wall because those are rectangular canvases. They have perfect right angles in the corners. And then I found some play food of Sadie's. These two shapes, well, the pizza and the piece of pie, they have acute angles. When you look at the sides of the pizza coming together, they form an angle right here, and it looks like it's pinching in. It is just so teeny tiny. It's acute. So it is acute angle because it is less than 90 degrees. And same thing with the piece of pie. It has an acute angle, less than 90 degrees, which is what a right angle equals. We don't need to worry about degrees yet, not talking about temperature or anything, but that's something a little more advanced with angles. It's kind of hard to find an obtuse angle, but I found this basket that I had in the playroom, and when you look at the sides of the basket coming down and across the bottom, it's opening up just a little bit more than a perfect right angle. I don't know if it's maybe right here you guys can see it better, but you can see how it's not going perfectly straight up and down. It kind of opens up more at the top. And so the side across the bottom, those two parts of this basket come together and create just a slight obtuse angle because it's opening up greater than 90 degrees. So we have right angles, acute angles, and obtuse angles. Our book does not use the terms obtuse and acute, but I wanted to teach you guys those words because now you can say you're smarter than our math book. So this angle here that's less than 90 degrees is a acute angle. And the one opening up greater is obtuse. So this is just a little extra learning for you, boys and girls. So if we look at Jason's shape, it says 2 angles are blank. Well, we looked and saw that 2 angles are right angles. So they want us to write the right, write the word right. Those are homophones. And blank angle is a right angle. Oh, I was confused for a second. One angle is, we're going to use the symbol less than a right angle, and one angle is greater than a right angle. Basically, one angle of his shape is acute, has a less than right angle, and one angle is obtuse. It's opening up wider. All right, if we go to the next page, boys and girls, it shows you a little activity that you could possibly do at home using 2 bendable straws. And you kind of just cut some slits in them to slide the 2 straws together. And you make this little device that can be used to create angles, because the bendable part would be in the corner, which would be like the vertice of the 2 rays coming together. And that's where it can open and close. I did not have 2 bendy straws at my house, so I couldn't make this. But this was just something hands-on if you wanted to make an item that you could use to show different angles. But we can practice making making some of our angles over here in the space provided. If I try to draw a perfect uppercase L as best as I can, that would be creating a right angle because I'm making a perfect corner. It is a just right angle. And I can make that same right angle look a little different going the opposite way, and that's still a right angle. Remember, obtuse angles are opening up very wide. So the space within here is obtuse. It is greater than a right angle. It's opening up really big. It's hard to write with this pen on my computer. And then we can make teeny tiny cute angles. There's a really small angle in between those rays right there. And that would be an acute angle. It is less than a right angle. It's acute. All right, let's move on to the bottom of this page. Okay, so down at our share and show, it says how many angles are in the triangle at the right? Remember the hint I told you, boys and girls? If a shape has 3 sides, like a triangle does, it's going to have 3 angles. Tri is a prefix that means 3, so the word triangle literally means 3 angles. And these angles are the spaces between the sides. Okay, so don't get confused between 3 sides and 3 angles. Number 2 wants us to use the corner of a sheet of paper to tell whether the angle is right, less than a right, or greater than a right. You don't really need to use a piece of paper. I think our eyes and the way the arrows are drawn can help us see if the angle is a perfect corner, that would be a right angle, or if it's greater or smaller. So when we look at this 6-sided shape, they're showing this angle here between these 2 sides. And I can tell that it's opening up wide. If it was a perfect right angle, a perfect corner, the other side should be coming straight down like that. But it's not. It's opening up wider, so that means it is greater than a right angle, or the new word I taught you was obtuse. So you can either put the greater than sign, or you can write a much neater obtuse word. Okay, number 3, we look at these 2 segments coming together, And that angle is looking like it's pinching in. If it was a perfect corner, then this side would need to come straight down. But it's not. It's less than that. So this would be a less than right angle, or it's just so teeny tiny. It is acute. It's an acute angle. Very good. And lastly, in this five-sided shape that looks like a house, we have one side coming straight down and the other side going straight across. And it has that special symbol in the corner, boys and girls. So when we see the special symbol in the corner that makes a square, that tells us that it is a just right angle. So this is a right angle. Just right. All right, nice job. Let's go ahead over to the next page. Write how many of each type of angle the shape has. So if we look at this first shape, kind of reminds me in baseball of like home plate. It has how many right angles? Remember, a right angle is shown by a perfect corner, and oftentimes it has that square symbol. So I'm going to highlight here. Here's 1, 2, 3. So we have 3 right angles. Keep going back and forth between the pen and the highlighter. 3 right angles. Do we have any that are less than a right angle? Well, remember, this shape has 5 sides, so we should have 5 total angles. So there are 2 more angles, boys and girls. Right here creates an angle, and also right here. But when I look at those angles, they're not pinching in. They're not really cute. They are looking pretty obtuse. So we're going to say that there are 0 less than a right angle. But then there are 2 that are greater, and those would be our obtuse angles. Okay, over to number 6. Do we have any right angles in number 6? It is a 4-sided shape, so I should be counting 4 different angles. I don't see any of those perfect corner symbols, so there are 0 right angles in this shape. None of the angles form a perfect corner. Now we need to look at the other kinds of angles that we have. Let's start in the bottom corners. This angle is pinching in, and this angle opposite is also pinching in. Those 2 angles, when they are pinching in, remember what we call them? They are acute. I don't know if you can see my cheat sheet up here in the corner. Those are acute angles. So we have 2 angles that are less than 90 degrees, and then therefore these other angles up top, it's kind of hard to tell, but they're opening up a little bit wider. So we have 2 angles that would be greater than a right. They are obtuse. And finally, we go over to number 7. We look at this shape here. You probably would recognize this as a square. A square has 4 equal sides. And one thing about a square is that it has 4 perfect corners. Now, I am not drawing those perfect corners with my pen, but there's that square symbol in the corner that tells us it is a right angle. So there are 4 right angles, and there are no angles left. So 0 that are less than a right and 0 that are greater than a right angle. Okay, on your own. You can feel free to pause the video if you want to try a few of these out by yourself and then come back and check along with me, or you can keep the video rolling and we'll do it here together. Okay, so number 8, use the corner of a sheet of paper to tell whether the angle is a right angle, less than a right angle, or greater than a right angle. Boys and girls, I just want to show you what they mean by using a piece of paper. If you get a piece of paper, whether it is a rectangle or a square, all paper has perfect corners, perfect right angles. So you could use this to kind of help you measure the angle that is in your book. You would simply align the paper in the corner of the shape. If the shape's angle is opening up greater, then you have a greater angle. It would be obtuse. If the angle is closing in from your paper, it would be an acute angle. And if it is perfectly the same, a perfect corner, it would be acute. Most of the time we can use our eyes to tell what kind of angle we have. So on number 8, we look here at this angle that they've highlighted with their blue arrows. I think that angle is pinching in. It's not a perfect corner, otherwise this one would come straight down. It is less than a right angle, or our special name for that is acute. It's acute angle because it is smaller. All right, this angle here has that perfect square corner. That means it is forming a right angle. It is just right. And actually, all these other angles within this shape are perfect right angles too, forming perfect corners. All right, on number 10, we have this 5-sided shape. We're looking at this angle here. Now, this one's kind of hard to tell. It looks like it could be a perfect corner, but I don't see that square symbol. So when I look extra careful at it, it is opening up greater than 90 degrees. So this would be an obtuse angle. It is opening up greater. So you could use the greater than symbol. All right, number 11, write how many of each type of angle the shape has. So when we look at number 11, this triangle, I see this symbol here. That is a dead giveaway that this is a right angle. So there's one right angle. And the other two angles in my triangle are pinching in, so they would be less than a right angle or acute. I don't have any that are greater. On number 12, this one is easy peasy. Look at all these symbols in the corners of this rectangle telling us that they are all perfect. There are 4 right angles and none that are less or none that are greater. And number 13, we have 2 giveaways, 2 angles that are right. They form a perfect corner. Look at this angle here in the bottom left corner. It's pinching in. It is acute. It's less than a right angle. And this one in the top left corner is opening up wide. It is an obtuse angle. It is greater than a right angle. All right, boys and girls, nice job so far. On number 14, think smarter. It wants us to describe the types of angles formed when you divide a circle into 4 equal parts. So in order to do that, I'm going to call on my math friend here to help us out. Let's see what he has to say. Maybe.
Yes. Yes. Oh, hi. I was just practicing my math using my baseball bat. But actually, it reminds me of a really batty question that I think you'll get a kick out of. And it's a question that involves geometry and circles and angles. And that really is what a lot of sports involve. It's geometry and circles and angles. So here's the riddle. The riddle is the following. Describe the types of angles formed when you divide a circle into 4 equal parts. 4 equal parts. Well, first of all, describe the angles formed. Let me just remind you what an angle is. An angle is just what you get when you take 2 rays and you align them along that starting point, which we call a vertex. So this dot here is a vertex, and then if you go out in one direction and you go out in another direction, that thing that we form right there is called an angle. So what we're going to do is we want to describe the types of angles, so that's what an angle is, that we get when we divide a circle into 4 equal parts. And so now here comes the baseball-like circle, which is what I was trying to hit to begin with. And so here comes, and you ready? Boing, 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 boing. Settle down, settle down. Boing, boing, boing. Now, I want to divide that into 4 equal parts. So I'm just going to kind of cut it into 4 equal parts. And so here are the equal parts. And you can see I have these 4 angles, 1 angle here, 1 angle here, 1 angle here, and 1 angle here. So now the question is, what can I say about those angles? Well, there are lots of different types of angles. Let me just show you a kind of a little picture I drew to just kind of show different types of angles. And in this shape that I drew, which has 4 sides, you'll notice something interesting. You'll notice that these 2 angles actually form the corners of a square. And so they're called right angles. So that's a right angle and that's a right angle. I'm going to show you a really cool way of writing a right angle. If you want to tell someone that something you have is a right angle, you put these little teeny corners in them, and those little teeny corners mean that in fact you have a right angle. So that's the marking that we use to say right angle. Whenever you see a little corner like that, it means that it's the angle that forms a square corner. So it's the kind of angle you would see on a square. Now, then there are these angles like this that are just visually, look at it, it's going to be less than a right angle. So this angle right here is an example of an angle that's actually less than a right angle. So some angles are actually less than a right angle. And this angle here actually is greater. In fact, this angle right here, in fact, is greater than a right angle. So you can see the angles come in lots of shapes and sizes. There's the right angles, which are these kind of nice ones. And then there are these ones that are smaller than right angles, less than right angles, and then these big ones that are greater than a right angle. So what do we get when we take a circle and divide it into 4 equal parts? What kind of angles do we get? Well, if I actually take a copy of the shape that we just were looking at, looks almost like a baseball diamond, kind of, that's been a little bit messed up. Check it out. It fits in perfectly. And we see that they're all the same, and so you see that what we have, in fact, are going to be 4 right angles. And I can actually draw them in now, because you know the secret code. That's a right angle, that's a right angle, that's a right angle, and that's a right angle. So you see we have 4 right angles, and so that's our answer. The answer is, what types of angles do we get? We get 4 right angles. And that is the answer. Isn't that neat? Isn't that neat that we get that answer? I think it's neat, neat, neat. Neat, neat, neat. 4 right angles. And you can see them. 1, 2, 3, 4. 4 right angles. Well, you now see what a right angle is, and it turns out that whenever you take a circle and you divide it into 4 equal angles, then in fact what you have, those parts, each part will represent a right angle. And right angles represent the corners of a square, and right angles are never wrong. Stop. All right. All right, it's back to my practice of math. Have fun thinking about math, and I'll see you soon. I know we're going to knock it out of the park.
All right, he loves math. All right, so to answer a question down at the bottom, we saw that he took a circle and he divided it into 4 equal parts, and those 4 parts created 4 right angles. Okay? Probably takes me longer to write this out than it should. Now, I want to point out something, boys and girls. When we had that circle and he split it into 4 equal parts, these up here where they're curved outer part of the circle come together with the line that we drew down the middle. Those do not create an angle because an angle, remember, has to be made by 2 rays coming together, and rays have to be straight. So this up here, this is not an angle because it is not formed by 2 rays. So the only angles we have are formed in the middle, and they are all perfectly right. Okay? All right, let's go to our next page here. We have number 15, unlock the problem. This is a go deeper, so let's really work hard on this, boys and girls. Holly drew the 4 shapes below. Which shape does not have a right angle? So which one does not have a perfect right corner? Well, part A says, what do you need to know? Well, looking at the question, we need to know which shape does not have a right angle. Okay, so let's type this out instead of trying to write all of that. Which one does not have a right angle? That's what we need to know. That's what we're trying to figure out. Which one does not have a right angle? Tell how you might use a sheet of paper to solve the problem. So, as I showed you earlier, the corner of a piece of paper creates a right angle. We can compare the corner of a piece of paper to the angles of our shapes to see which shape does not have a right angle. But maybe just by using our eyes, we can also tell. But to answer the question, we could say paper, I can spell it right, paper has right angles in each corner. Make this a little smaller. Okay, so we can compare the corner to the angles in the shapes above. Maybe we can compare the corners to the angles in the shapes above. But you might not have to do that using a piece of paper, but it's not a bad idea if you are having trouble trying to find, if it's a right angle greater than or less than. I'm going to see if I can. Let's see here. Nope, don't want that. Trying to find a shape that I could use. Well, let's see if I can just make my own. How about that? And we're just going to group these together. Bear with me. All right, so this makes a perfect right angle. So I'm going to use that to compare on my shapes. And you can see that shape letter Q has a right angle. R has at least one right angle. Now on S, they made it a little tricky because they turned it. So let's see if I can kind of try to match this up. There you go. So you can kind of see there that S has a right angle. What about T? Does T have any right angles? Well, if I go here, this angle is greater than a right angle. What about if I turn it a little bit? No, because now it's not the same on the bottom. Let's try to go over here. That doesn't work. And this bottom one, bottom right corner, no, that doesn't line up either. So boys and girls, I think we found our answer. Which shape does not have a right angle? all this stuff here in the middle, like I don't know what all that jumble is. We're just going to skip that. I think it's clear to see that shape T does not have a right angle. If you went through and practiced all the angles that the shapes have, congratulations, you have more patience than me. But in case you did, I will go over the answers with you so that you can check. Shape Q has two right angles, these two perfect corner angles, and it has one angle that is greater than a right angle and one angle that is less. This angle up here is less than a right, and the bottom is greater than. Shape R, because it is a perfect rectangle, has four right angles, and that makes it easy because then there are 0 angles that are less or greater. Shape S is also like shape R in the sense that it has 4 perfect corners. Even though this shape, which we would call a square, is tilted or it was turned, these angles formed here are still perfect corners, perfect right angles. So there are 4 right angles, 0 angles greater, and 0 angles less. And then shape T, we discovered did not have any right angles. But instead, let me move my angle maker out of the way. Instead, shape T had an angle here that was pinching in, and opposite, another angle pinching in. So that makes it less, 2 angles that were less than a right. And then the other angles are opening up greater. Remember, they are obtuse. So then there are 2 angles greater than a right angle. I guess that wasn't too bad. All right, number 16, circle a number or word from each box to complete the sentence to describe all of the angles in this shape. There are 2, 3, or 4 right angles. Well, because I see those symbols in the corner here, these symbols tell me that those 2 angles are right. So there's 2 right angles. And 2, 3, or 4 angles that are either greater, less, or greater than a right angle. Well, look at these angles here. These angles are opening up wider. These are big, obtuse angles. There are 1, 2, 3, 4 of them, and they are greater than a right angle. Excellent. Home stretch, boys and girls, practice and homework page. If you want to try this on your own, go ahead and pause the video and then come back to check your answers, or you can hang out with me here and continue on together. So let's take a look. We need to tell what kind of angle these shapes have. And number 1 was done for us. The angle shown here is less than a right angle. Okay. Let's see here. These angles that are shown in the corners by those symbols are perfect, just right angles. Okay, so this would be a right angle. And then on number 3, this angle here is opening up really big, so it is greater than a right angle. Or the word we learned for that when it's greater is obtuse. If you can read my writing. Okay, number 4, 5, and 6. We need to tell how many of each kind of angle the shapes have. Number 4, I love it because all 4 angles have that perfect corner. Perfect, just right. So there are 4 right angles, 0 less, 0 greater. All right, let's look at number 5. This shape is interesting. It does not have those perfect corners, so 0 right angles right off the bat, we can say that. When we look at these angles, look at them. They are opening up wide. Look carefully. Sometimes it looks like a perfect corner, but they're opening up wider. All 5 of them are. I'm going to say 0 that are less than a right angle. All 5 of those are greater than a right angle, which means they are obtuse. And on number 6, I first check how many right angles there are. I see 2 perfect corners, so 2 right angles. Oh, look at this one. This one's really big. And same here opposite it. Those are really big angles opening up wide. But also these other angles are opening up wide. Remember, less than right would be really small, pinching in. 0 of those angles are doing that. 4 of them are opening up greater than a right angle. All right, number 7, Jeff. Hey, Jeff, if you're watching this video, you're famous in our math book. Jeff has a square piece of art paper. He cuts across it from one corner to the opposite corner to make 2 pieces. What is the total number of sides and angles in both of the new shapes? Well, let's do what Jeff did. He has a square piece of art paper, so I'm going to make a square piece of art paper, and he cuts across it from one corner to the opposite corner to make 2 pieces. So let's do that. He cuts across it from one corner to the other. Now he has 2 pieces. What is the total number of sides and angles in both of the new shapes? So if you look, both of these new shapes look like what? Triangle. So here's 1, 2, 3 sides on that triangle, and then 1, 2, 3 sides on that triangle. We have to count that again because that side, that shared side down across the middle, is shared between both triangles. So if the purple triangle had 3 sides and the blue triangle have 3 sides, what is 3 plus 3? 6. Thank you for whoever shouted out the answer. All right, so there are 6 sides. This is where I miss being in class and hearing you guys interact with me. I feel like I'm just talking to myself right now. 6 sides, and we have to also tell how many angles the shape has. Remember, angles are formed between 2 sides connecting at the corner vertice. So here's an angle. That's an acute angle. It's teeny tiny. It's acute. Here's another acute angle. So there's 2 teeny tiny acute angles. And then over here, 3 acute angles, 4 acute angles, and then these perfect corners. 5, 1 of those is right, and 6, another right angle. So all together we have 1, 2, 3, 4, 5, 6 angles. Remember, if the shape has 6 sides, it's going to have the same number of angles. And even though the shapes have 3 sides each, we were adding them together. Okay. Let's go ahead and practice on number 8. Just wants us to draw an example of a shape that has 1 right angle. So make a perfect L. And then you can close it up. This shape has a right angle, has 1 perfect corner. Then we need a shape that has at least 1 angle that is less than a right angle. So I'm going to make this shape, which is another triangle, but my angle right in here is acute. It's so teeny tiny. And then a shape that has an obtuse angle, which is greater than 90 degrees, opening up very wide. Connect it there. All right, so this angle right here at the bottom would be obtuse. So even though I drew 3 triangles, each of those triangles are different because they have some different angles. All right, next page. Last one, lesson check. Describe, what describes this angle? So this big angle here, look at it, guys. It's opening up very big. What kind of angle would that be? Shout it out if you know it. Obtuse. Yep, it's an obtuse angle, or maybe you said greater than a right angle. Either one of those answers. Okay. On number 2, how many right angles does this shape have? Remember, right angles, perfect corners. 1, 2, 3. 3 right angles. Okay, perfect. All right, spiral review. Let's do this. What fraction of the group is shaded? Ooh, I love fractions. Well, let's look at our group. There are 1, 2, 3, 4, 5, 6 circles. The total number is our denominator down at the bottom. And since one of those circles is shaded, I would write 1 as my numerator. 1/6 is shaded. Number 4, compare the fractions. Ooh, 4/8 compared to 3/8. All right, this is a good one. Our denominators are the same, boys and girls. So think of a pizza, 2 pizzas cut into 8 slices each. You eat 4 out of those 8 slices, and your friend only eats 3. So 4 is greater than 3. 4/8 is greater than 3/8. Number 5, what is straight, continues in both directions, and does not end? Here's a little riddle. Here's a picture to help you. What do we call that? Straight, and it goes on and on and on. It is called a line. And number 6, how many line segments does this shape have? Line segments is fancy for sides, so let's count them. 1, 2, 3, 4, 5, 6, 7. It has 7 line segments. All right, boys and girls, thank you for joining me on this math video. I hope you enjoyed doing this along with me. I will be making another video for lesson 3. If you have any questions or need some additional help, please reach out to me. I would be more than happy to go over anything that you have learned today. So I will talk to you guys soon. Have a great rest of your day. Bye. Maybe it doesn't want to seem to stop recording me. You guys might be stuck with me for a while.